right, 9-3. So on Monday we will review all of 9-1, 9-2, 9-3 with like a little review worksheet, and then on Tuesday you'll have a quiz on these 3 lessons, okay? So 9-3, we're going to now do geometric sequences. So on 9-1, we learned, all right, during notes you got to turn the games off, okay? So during, after notes, that's fine. You can turn your NCAA back on. I don't mind at all. But right now we're going to do this. Okay, so yesterday we learned all about sequences and what they are and how to find formulas for them. But then we were given a specific kind, and that was arithmetic. So now we're going to do geometric. So what is a geometric sequence? Well, for geometric, we're going to talk about a ratio. Okay, don't be scared. It's not the kind of ratio like proportions that we did last chapter. But a ratio. So a geometric sequence is going to have a constant ratio between consecutive terms. Constant ratio between consecutive terms. All right? And we call that number, or that it's going to be a number, but we call it R. R for ratio. Yesterday, we had D was the common difference for arithmetic. Today, we have R as the common ratio. Basically, what it means is for a geometric sequence to be a geometric sequence, you either multiply or divide. Multiply or divide by a number to get to the next one. So for arithmetic, we add or subtract. Geometric, we multiply or divide. Okay? And the way that you can find R is pretty easy to do. Because if you're like, what's it multiplying by each time? I can't figure this out. What you do is you take a term in your sequence and you divide it by the term right before it. Okay? That's how you find out what R is. So if I wanted to find what R is on a sequence, I could take the 5th term and divide it by the 4th term, and that'll give me R. All right, so here we go. Number 1. Is this sequence geometric, arithmetic, or neither? Because, you know, they're not always just either adding or subtracting or multiplying or dividing. You could have different kinds of sequences here. Geometric, arithmetic, or neither. Okay? Here we go. Letter A. 5, 10, 15, 20, 25. Okay. You need at least 3, by the way. If I just stopped at 5 and 10, then I can't tell what that is. It could be anything, right? All right, so 5, 10, 15, 20, 25. What kind of a sequence is this? It's arithmetic. Perfect. This is an arithmetic sequence. You did those last night. And the common difference is what? 5. Perfect. Common difference between terms is positive 5. Okay, how about this one? 5, 10, 20, 40, 80, ... So I started with the same 2 numbers on purpose so that you can see that you have to get to the 3rd one, really, to see what's going on. Yes? Geometric, perfect. Perfect. Common ratio. Yep. Geometric, and R is 2. We're multiplying by 2 each time. If you have trouble figuring that out, take 40 and 20. And you take 40, divide it by 20, that'll give you 2. Any consecutive terms, take the 1, divide it by the 1 before it. Okay, how about this one? 1, 2, 6, 7, 11, 12, ... Neither. Yeah. I could think, okay, I'm either adding 1, but then I would add 5. Okay, well, that's not it. And then I think, okay, I'm multiplying by 2, and then I'm multiplying by 3. Well, that's not it either. They have to be the same number. So this one would be a neither. None of the above. I don't even know what that pattern is. Do you? 1, 2, 6, 7. Oh, we could probably figure that out. All right, that would be kind of fun. Part B. So part A was just describing what a geometric sequence is. Part B, I'm going to give you the formulas. They're on the board already. We have 2 types of formulas here. Just like arithmetic, we have a recursive formula and explicit. Okay, here's the recursive formula for a geometric sequence. It's going to be a sub 1 equals. You have to tell me where to start. If you tell me, hey, Miss Price, I'm going to give you a sequence, take numbers and multiply by 5. Okay, where should I start? You got to tell me where to start at. Okay, oh yeah, you're right, start at 3. Perfect. All right, and then you have to tell me to find the nth term, whatever term in the sequence I'm looking for. I'm going to take the one before it, called a sub n minus 1, that just means the previous term, and I'm going to multiply it by r. Okay? So that is your recursive formula. You'll use that for geometric. We already had a recursive for arithmetic. It was plus d. This is times r. It's exactly the same. That's the only thing that changes. All right, and then explicit is a little different. Explicit formulas. Did you notice on that last problem when we're multiplying by 2, do you notice everything is doubling? And when things double, do you know what that is? It's exponential. It's exponential, right? It's increasing really quickly. We remember that from our exponential chapter. So an explicit formula would look like this. A sub n equals a sub 1. I usually will put r in parentheses to the n minus 1. And that should look like exponential growth to you, or decay, depending. And that's it. Now, there is a side one that's not used as much, but if you want to know it, it's a sub n equals a sub 0 times r to the n. But this is the one that I use most of the time, probably all the time, and then that. So you don't really need that one, but some people like it. I'm just giving it to you because, you know, I want you to get your money's worth today. All right, so here we go. Let's do some now. Are you ready? We've got our formulas. We're ready to go. Number 2. All right, so here is a sequence. 11, 33, 99, 297. See how quickly these increase? Very quickly, right? What we're going to do is we are going to write a recursive formula and an explicit formula. Okay? And with explicit, we don't have to do any simplifying, just leave it as is. All right, recursive. You should be doing pretty good at recursive by now. We did it on 9.1 and 9.2. Now we're going to do it on 9.3. So tell me where to start. A1 equals 11. Good. And a sub n equals a sub n minus 1. What are we doing each time? Times 3. Multiplying by 3. And if you don't know that, you can always take any of the numbers and divide it by the one in front of it. 33 divided by 11, 3. 99 divided by 33 is 3. 297 divided by 99. I'm thinking it's 3. Yeah.
Is it okay if we write like our recursive formula like that instead of putting 3 in front of the a?
Yes.
Okay.
I prefer this. Okay, now let's do an explicit formula. Explicit formula, I have it on the board. It is right here. This is the one I'm going to use. So I'm going to do a sub n equals a sub 1, which is 11. R is my growth factor. In this case is 3 to the n minus 1. And that would be the answer. You don't need to fix that at all. Don't, do weird stuff. Leave it alone. If you wanted to test it by plugging in a number, you could. You could test it. Okay, now I'm going to ask you a little follow-up question. Find the 10th term. All right, and you have options. Sometimes options are good. Sometimes options are confusing because it's like, I just want to know one way to do it. Well, here are your options. You have 4 already. You could keep going with the pattern and get to the 10th term. I think that's a waste of time, personally. If I'm going to find the 10th term, and I already have an explicit formula for it, why don't I just plug it in there? So I want to find the 10th term. I'm going to do 11 times 3 to the 10 minus 1. Okay? So you can go to your calculator. 11 times 3 to the 9th power. You know how to subtract 10 minus 1. And you get 216,513. Okay? All right, let's do another one of those. Number 2. 3. Thank you. Number 3. Okay, how about, let's do this one. I don't like that one. I like this one. Negative 1,000, 100, negative 10, 1, ... All right, so we have an infinite sequence here. It goes on forever and ever and ever, never stops. And I want to write a recursive formula for this and an explicit formula. Okay? Recursive and explicit. You want to try it? Or is it a little tricky? Might be a little tricky. Mm-hmm. Yes, negative 1/10. Did you say 1/10? Yeah. Mm-hmm. Okay, so a sub 1 equals the first term. You'll get a point for that on your quiz, so write that down. And then a sub n equals the previous term times, and let's say you're not sure what it's multiplying by. What you can do is take the second term, divide it by the first term. And you can do negative 0.1. You can change that into a fraction, negative 1/10. I like that. So I'd go times negative 1/10. Okay? All right, so now our explicit formula, we know what a sub 1 is. We know what r is now. Let's go ahead and write it in its explicit form. So a sub n equals negative 1,000 times negative 1/10 to the n minus 1. There you go. There it is. And I could ask you find the 9th term, 10th term, 11th term, whatever. And you could just use that. All right, one more of these, and then we'll do the last part. Number 4. No, it's warm in here, no? Oh, okay. All right. This one's a little different. We're going to write an explicit formula, given that the first term is 2 and r is 10, and then I want you to find the first 5 terms. Here we go. Write an explicit formula. You're given every piece of information you need for an explicit formula. Now, I think I'm going to put a parenthesis around that. I really like the parenthesis. Especially when it's a negative r, the parenthesis has to be there, so let's just go ahead and make that parentheses. Plus, you're so used to parentheses when we did this in exponential stuff. Yes? You like that? You're okay? All right. Yeah. Okay. So, write an explicit formula. So my explicit formula, I need a sub 1 and I need r. I got them both. Just plug them into your formula. So we have a sub n equals 2 times 10 to the n minus 1. There it is. Now, there's 2 ways to do the next part. The next part, I need the first 5 terms. One way is to take 1, plug it in. Take 2, plug it in. I just think that takes too long. Let me show you a better way. What's my first term? 2. What is this doing each time? Times 10, right? Yeah. 2 times 10? 20. You don't even need a calculator, do you? You just put a 0 on the end, right? 10 times 20, 200, 2,000, and 20,000. Perfect. See how quick that was? Nice. All right, last part for you today. Letter C. Pretty quick, huh? We are on extended lunch, and we are out at 10:50. All right. So the last part, remember the last part of arithmetic sequence? Do you remember what we did? The arithmetic, starts with an M? Mean, the arithmetic mean. Okay, we're going to do the geometric mean. Like I'm mean. Geometric mean. All right, the geometric mean is going to be found a totally different way. Arithmetic was you add the numbers, divide by 2. It's their average. The geometric mean is found by taking the square root of the product of the two numbers. Okay? So you're going to multiply the numbers together and then take the square root. That's going to find the middle of a geometric mean. So for example, number 5. Suppose that we have 20 blank 80. And we got to find that middle number. Okay? And they told me that this is a geometric sequence. That's important. They have to tell you which one it is. If it's arithmetic, you're going to do it a different way. So you're going to take the product, which is 20 times 80, and you're going to take the square root of that. You can use your calculator all you want. And the answer is 40. The answer is actually 40 or negative 40, technically. I'm not going to be picky about that. This could be multiplying by negative 2 each time. So it could be negative 40, but we're not going to worry. We're just going to find the positive one. And then number 6, suppose they give us 19,683, and then we have 1, 2, 3 blanks, and 243 is at the end here. Okay? And they want us to fill in the blanks. Find the missing numbers of the geometric sequence. Geometric. Okay, arithmetic would be totally different. And do you remember how we did it yesterday? Yeah? That's how we did it yesterday, but these are geometric, so we're going to take the outside 2, and we're going to multiply them together and take their square root. And that's going to give us this middle term here. So take 19,683 times 243 and take the square root of that. And do it by hand. Just kidding. Do it in your calculator. You're like, this is a non-calculator test? No. This whole test is calculator. And they should come out nicely. If they don't, then you did something wrong. So this would be the square root, which would end up being 2187. Okay? And now to do the other one, same thing. You don't have to show work. If you get this and you know how to do it, that's fine. So square root of 19,683 times 2187, and I get 6561. And then I'm going to do it one more time over here with these two numbers. So the square root of 2187 times 243 should get 729. So start with the middle number and then work your way out.